So we've been talking about converting lengths, and then we talked about converting areas, and now we're going to talk about converting volumes. So before we get into converting volumes, let's go ahead and review volume a little bit, what it means, and how to measure it. The volume of a three-dimensional figure is the amount of three-dimensional space enclosed by the figure's boundaries. Volume is measured in cubic units, such as cubic inches or cubic centimeters. So let's take a look at this diagram here. We literally have a cube, and that cube has three dimensions, length, width, and height. And if all those dimensions are 1 centimeter, then the space inside that cube is 1 cubic centimeter. And this would be true with any unit. If this was 1 inch by 1 inch by 1 inch, then the volume inside there would be 1 cubic inch. Can you take your hands and put them a foot apart? Like if you're holding a cube that's a foot by a foot by a foot, put your hands on the top and bottom of that cube, the front and back of that cube, the sides of that cube. Get a visual of what a cubic foot would look like. If you need to even get a ruler to get an idea about a foot, I want you to really understand what a cubic foot is. Okay, similarly, can you take your fingers and make a cubic inch? Put, between your thumb and your index finger, an inch, an inch, an inch. Picture what a little cubic inch would look like. Do you think a standard dice is smaller or larger than a cubic inch? Picture a cubic inch. Is that bigger or smaller than a dice? I think it's a little bit bigger. I think a cubic inch, my dice are not that big. So part of really being able to understand how to work with volume and area is understanding what it is, how big it is. If I say cubic inch, do you have a feeling for how big that is? All right, so let's talk about how to find volumes. A rectangular box has a width of 4 inches, a length of 5 inches, and a height of 3 inches. Use the figure to explain why the volume of this box is equal to 3 inches times 4 inches times 5 inches. Then compute the volume, include units. Now some of you know that to find volume we take length times width times height, but why is that? Why does that work? So let's take a look at this picture over here. We have a box that is 4 inches wide. So that is right here. Can you see that? Let's highlight that. Let's do 4 inches wide. That's these 4 inches here. And then we've got 3 inches. That would be how tall it is here. And then we've got 5 inches, which is this distance here. So you could take sugar cubes or dice or whatever you have and try to stack, make a box that has these dimensions. Okay? Then how many of those little cubes would you need in order to make that? Well, we could think of it as layer by layer. So the very first layer, the very first floor, you'd have 5 inches by 4 inches, right? So how many cubes would you need for that bottom layer? Well, you would need 5 times 4, or 20, right? You would need 20 little blocks to make that bottom layer. Then you would need 20 blocks to make the top layer, and you would need 20 blocks, the middle layer, and 20 blocks to make the top layer. So you would need 3 times 20 blocks. Now where did we get the 20 blocks? Well, we got the 20 blocks by taking the 4 times the 5. So really what we ended up doing here was 3 times 4 times 5 to get 60. So visualize whatever your dimensions are on the bottom, that's how many cubes you need for the bottom layer. And then whatever the height is, that's what you'd have to multiply that by to stack them up, all right? You can write that out in a way that makes sense to you, but I want you to understand why we multiply those together to find volume of a box. Number 2, how many cubes with an edge length of 1 inch are needed to fill the box shown at the right? And then part B says if the cubes had an edge length of 2 inches, would you need more or fewer cubes to fill the box? And then find that. And then C is with a 1/2 inch cubes. So I want you to pause the video and work through number 2, and then we'll talk about it. So let's look at A, which I'm sure most of you got fairly easily. We're just going to multiply the 4 inches times 10 inches times 3 inches. The order you multiply these in does not matter. Multiplication is commutative, so it doesn't matter. Oops, I made a mistake there. Do you see it? So make sure that you're putting your units in when you're doing your multiplication. Do you see my mistake? So inches times inches times inches is not square inches, is it? It is cubic inches. There we go. Cubic inches times inches times inches. There's 3 factors of inches. That's cubic inches. Now for B, this is where it makes me a little, I wish that we could have a conversation, because there's more than one way to do this and more than one way to think about it. So I'd be curious how you thought about it. But I'll go ahead and talk through one way we could do this. So if the cubes were 2 inches on each side, you could think about how many cubes you could stack. So if this was 4 inches high and the cubes were 2 inches each, that means you could fit 2 cubes here. So I'm going to change this to 2c, meaning 2 cubes. For the 10 inches, I could fit 5 cubes. 1, 2, 3, 4, 5. I could fit 5 cubes along the bottom there. Ooh, should I try to draw that? I don't know. That might not be a good idea. That's not bad. Okay. Now for the 3 inches, I could fit a cube and a half. So let's say I could cut these cubes in half. I could fit 1.5 cubes. So now if I'm measuring in these dimensions of cubes, I'd have 2 cubes times 5 cubes times 1.5 cubes. And that would give me 15 cubes if each cube was 2 inches on each side. Now what's another way we could think about this? Let's say, and I'm going to guess some of you guys did it this way. Let's look at these cubes that are 2 inches on a side. Okay, so let's say I have a cube that's 2 inches on each side. 2 inches by 2 inches by 2 inches. What's the volume of that cube? Well, it would be 2 inches times 2 inches times 2 inches, or 2 inches cubed. 2 times 2 is 4, times 2 is 8. So the volume of that cube is 8 cubic inches. Now I know the volume inside this box is 120 cubic inches. So if one of these cubes takes up 8 cubic inches, how many of these cubes could I get in this box if I could cut them? Okay, some of you may have done it without being able to cut them, which is clever as well. So the number of cubes I could fit would be 120 cubic inches divided by 8 cubic inches. How many of those 8 cubic inches will go in there? So hopefully 120 divided by 8 is 15, which it is. So 15 cubes would fit in there. Now if you didn't get part C, maybe looking at how I did the 2 different ways to do part B, and there might be other ways as well. If you didn't get C, pause the video and try that. Alright, so we could do C in a similar way, these 2 different ways. If the cubes had an edge length of a half, let's copy this picture down here. If the cube length had a length of a ½ inch, how many could I stack on this 4 inches here? A half, a half, a half. How many? Can you visualize that? That would be 8, right? Because it would be two cubes for every inch. So I could fit 8 cubes this way. This is 10 inches. So if each cube was a ½ inch, I could fit 20 cubes there. And if this is 3 inches, then I could fit 6 cubes along that edge. So using that technique, the volume would be 8 cubes times 20 cubes times 6 cubes, which would be, what would that be? 160 times 6, which is 960 cubes. That's one way to do it. Another way to do it would be to think about the volume of this cube. This is kind of interesting. So if this cube is a ½ inch on each side, the volume of this cube would be 1/2 of an inch cubed. So what's 1/2 times 1/2 times 1/2? It would be 1. 2 times 2 times 2 is 8. Multiplying fractions is easier than you think. 1 times 1 times 1 over 2 times 2 times 2. So each little cube would only take up a volume of 1/8 of an inch. Now we know the volume of the whole entire box is 120 cubic inches. So if we want to see how many of these little cubes with a volume of 1/8 of an inch will fit inside, then we need to divide. Alright, so 120 divided by 1/8 is the same as 120 times 8, which would give you 960 cubes. Alright. Number 3, write down a formula for the volume of a rectangular box with length L, width W, and height H. So to find the volume, we're simply going to take length times width times height. Alright, let's try another conversion. How many cubic feet are in 1 cubic yard? Use the fact that 1 yard equals 3 feet together with the figure to the right to answer the question. So this looks like a Rubik's Cube, doesn't it? If you remember what a Rubik's Cube is. So in this diagram, this whole thing is a cubic yard. So this distance is 1 yard. This distance is 1 yard, and the height is 1 yard. So that means that the volume inside this large cube is 1 cubic yard. We know that there are 3 feet in 1 yard. So in this diagram, this distance is a foot. That's 1 foot, 1 foot, 1 foot. That's showing us 3 feet in a yard. So therefore, one of these little cubes, let me erase this right here. One of these little cubes, I'll do a little dotted thing here because we can't see it all. One of these little cubes in the front corner, that's a cubic foot. So how many cubic feet are in a cubic yard based on that picture? How many of the little blocks would it take to make the big block? All right, well, hopefully you're thinking I would need 9 of the cubic feet to make just the bottom layer. If we think about that diagram we were looking at before with the stacks, like this, it would take 9 to make the bottom layer of this one, and then 9 more to make the middle layer, and 9 more to make the top layer. This is one way to think about it. There's other ways to think about it, but if you came up with 27 cubic feet, you are on the right track. Now remember when we were doing area, one way we could find our conversions for area was squaring both sides. We can do a similar thing with volume. So we know that 1 yard is 3 feet. If we want to make a conversion for area, we square both sides, right? We did this in the last video. So we would learn that 1 square yard is 9 square feet. But what if we want to make a conversion for volume? Well, now we need cubic units. So instead of squaring both sides, we're going to cube both sides. 1 times 1 times 1. 1 times 1 times 1 is 1. Yard times yard times yard is cubic yard. So here we have 1 cubic yard. On the right-hand side, we need to do 3 to the 3rd power. So 3 times 3 times 3 is 27. And feet times feet times feet is cubic feet. So this is how we could come up with this conversion factor by cubing both sides, but hopefully you could also visualize that 27 cubic feet are required to make 1 cubic yard. So let's do a similar thing with 12 inches and 1 foot. We have our length conversion, 12 inches equals 1 foot. What would the area conversion and the volume conversion be for these? Go ahead and write those out and start the video when you're done. All right, so this one we need to square both sides. To get the area conversion, we're going to square. So that's going to give us 144 square inches is 1 square foot. To do the volume conversion, we're going to cube both sides. So 12 to the 3rd power is 1,728 cubic inches in 1 cubic foot. Let's put these conversions to work and solve a problem. A fish tank has dimensions 12 inches by 27 inches by 33 inches. Find the volume of this tank in cubic feet in two different ways. Approach 1, convert the dimensions of the tank to feet, then find the volume. Okay, so we're going to take each of these dimensions here, and we are going to convert them to feet. So many feet by so many feet by so many feet, and then use those to find the volume. All right, that's approach 1. Approach 2, we're going to find the volume of the tank in cubic inches and then convert that into cubic feet. I'd really love it if you'd give this a try on your own and then pause the video when you're ready to check it out. Or start the video when you're ready to check it out. All right, let's do approach 1. So if we convert each of these into feet, so we want to convert 12 inches into feet, so we're going to multiply that by 1 foot over 12 inches. We could kind of do this one in our heads. Some of these you could just do in your head, right? 12 inches is 1 foot, so the 12s cancel and we get 1 foot. And we're going to convert 27 inches into feet, so that's 1 foot over 12 inches, and that's going to give us 27 divided by 12 is 2.25 feet. And then lastly, we're going to convert the 33 inches into feet. We're going to end up dividing by 12 again. And 33 divided by 12 is 2.75. I'm going to run out of space. So now we have the dimensions in feet. So we could find the volume by multiplying the 3 dimensions in feet. 2.75 feet. And that will give us 6.1875 feet times feet times feet is cubic feet. Okay, let's try approach 2. So approach 2, we're going to find the volume of the tank in cubic inches. So we're going to use these to find the volume of the tank. So the volume is 12 inches times 27 inches times 33 inches. And we get 10,692 cubic inches. Inches times inches times inches. So now we want to convert 10,692 cubic inches into cubic feet. So we're going to use this volume conversion factor up here, this guy. Or we could write out the length one 3 times. But let's just use this one. So I'm going to put cubic feet in the numerator and cubic inches in the denominator, so I can cancel those cubic inches. 1,728 cubic inches. So the cubic inches are going to cancel. So let's divide and see what we get. And hopefully we get the same thing we did when we did the other method. 6.1875. Yay. That makes us happy. We should get the same answer, right? All right, that was fun. Looks like it's time to fill our tank, and we have 20 gallons of fresh water to pour into the tank. Is this enough water to fill the tank? Use the fact that there are about 7.48 gallons in 1 cubic foot. All right, so we know our tank is 6.1875 cubic feet. So we need to figure out how many cubic feet of water is the 20 gallons. So we want to figure out 20 gallons is how many cubic feet. So we want to convert 20 gallons into cubic feet. All right, so let's do that. Here's our conversion right here. Right here, this is equal. 7.48 gallons is 1 cubic foot. You got it? Which one's going to go on the top? Which one's going to go on the bottom? Let's put our gallons down here so those will cancel. And 1 cubic foot. So 20 divided by 7.48 is 2.67 cubic feet. So we've got 20 gallons of water, which is 2.67 cubic feet of water. That's how much water we have to try to fill our tank, to pour into the tank. Do we have enough to fill our tank? No, we're woefully short here. We need a little more than 6 cubic feet to fill our tank. So our poor little fishies, we're more than 1/3 full, but we need some more water. So maybe another question we could ask is how many gallons would we need? All right, so we would want to convert this into gallons, and then we could figure out how many gallons we need to fill all the way to the top, which you probably don't want to fill all the way to the top because your little fishies might jump out. All right, let's go ahead and do this last one. You guys give it a try. When you unpause the video, it's going to be completely done for you, and you can check and see how you did. So here's 2 different ways that you could do it. You could start with your 3.2 cubic miles and then multiply by 3 factors. You need 3 factors to cancel out the cubic miles. We got cubic miles, mile, mile, mile. Those would all cancel out. Multiply and we get 13.4. The other option is to take your conversion factor and cube both sides of it to create a new conversion factor. So here's your new conversion factor for volume. Okay, so we're taking our conversion factor for length, we're cubing both sides to create the conversion factor for volume, and then we're using that conversion factor to multiply by 3.2 cubic miles, and we end up with the same answer. Now, as far as what's bigger, 3.2 cubic miles or 3.2 cubic kilometers, a mile is more than a kilometer. You can go back and look at the last section where we had some diagrams of that. So a cubic mile would be more volume than a cubic kilometer.